Hi Security Tube. Welcome to part 20 of the Wireless LAN Security Mega Primer. So before I begin, big apology for a long break. I really wanted to finish this series around 10 days back, but a lot of interesting things happening and a lot of good news, for Security Tube overall, which I will announce in a separate video. But now I'm back, and I also have a pending backlog of emails to answer. A lot of people have sent me emails, and I will respond to that within the next 2 to 3 days. So, once again, apologies for the delay on that. Anyway, so now we are back and going to start WPA WPA2. I guess a lot of you are waiting for that, right? Many of us consider Web to be pretty script kiddie-ish, and WPA is for the grown-ups. So here goes. So we all know that web was broken. We've stabbed it. You kind of killed it. You kind of broken the web key probably under 5 minutes. And I guess the IEEE committee and the Wi-Fi Alliance said, well, that's enough. People have made too much mockery out of the encryption scheme we designed. So let's design something more solid. And they said, well, the problem is hardware changes may be required for something which is very robust and solid. So let's first propose an interim solution. And this is what they call WPA, Wi-Fi Protected Access. And basically this interim solution has the following things. First, it is going to be based on web, but something which would probably end up protecting the web key from getting cracked, right? And this is what is TKIP, where we have a lot of interesting things like very fast key rotations. The web key or the key used for the encryption is dynamically derived at runtime, a lot of stuff which we will look at later. And the most advantageous fact of using TKIP is hardware changes are typically not required. Only firmware updates would be required on the devices. This is huge because old legacy devices could support TKIP with simple firmware changes. Now, having said this, the committee also said, well, this is just a short-term solution and we need something more powerful and robust and secure. And they said, well, this is what WPA2 is going to be. So WPA2 is the long-term solution and is basically based out of what is called the 802.11i draft. Now, in contrast to WPA, this uses CCMP, which is based on the AES encryption scheme. And this almost necessarily requires hardware and firmware updates, right? So from here on, things become more interesting. Both WPA and WPA2 have a personal and enterprise edition, right? The personal edition uses something called PSK or pre-shared keys, as many of you may already be aware. And the enterprise edition is based on the .1x protocol and radius server, which is used at the backend typically, any authentication server. So WPA WPA2 is more challenging even from a technical perspective and even from understanding the whole crypto background. So I'll try to do, I'll probably try to kind of present it in a way which is easy to understand. Hopefully I will succeed. And .1x is even more interesting, and you're in good hands because I was one of the developers in Cisco's Layer 2 security team who added and created a lot of code for the .1x protocol on the Catalyst 6500 series of switches. So I had to read through the standard multiple times, and I think even though it's been 7 years, I probably still remember most of the things in there, right? So that will be fun. So before we move in and have a look at all of that encryption and mathematics, let's try and understand something more fundamental. How does the client even get to know what is the encryption being used by the AP, whether it is WPA, WPA2, web or whatever? This also lays a very interesting background on how you can make any client connect to you. So a lot of people asked questions over the last 19 videos. Well, what if the honeypot, or sorry, what if the access point is WPA WPA2? Can we create a honeypot and have the client connect to us? Well, as I had told you, I will answer all of those questions, and now we are coming to exactly how. So in short, the answer is yes, it is possible to have a client connect to you by advertising credentials of an access point which the client is aware of in its preferred network list and will connect back to you, right? So without further ado, let's first go ahead and configure our client. So I'll go to wireless settings and let's just click manual wireless setup. Security mode is WPA personal, and I guess TKIP. The pre-shared key is already added to some default key. So if you have forgotten what that is, well, either you could rewrite that, or one of the easiest ways is just to search for pre-shared key in the source code. This is very funny, but this is like one of the most simple hacks out there, right? So the pre-shared key is ABC12332, not a very interesting one, right? So let's go ahead, apply these settings so that our access point is on WPA personal using PSK, and here is the little friendly access point. It's up and running now. I've connected to the access point over the wired LAN. Now let's go back to our hacker machine, which is Backtrack2. As always, a quick check to ensure Mon0 is up and running and is created. And let's run arrow dump ng on the Mon0 interface. Maybe restrict the channel to 1 because I'm aware that the access point is on channel 1. Right? And you can see that it is WPA encrypted, cipher is TKIP, and auth is PSK. So to analyze what is really happening, let's open up Wireshark. And let's start sniffing on the Mon0 interface. There's going to be a lot of beacon frames. So first let's analyze the beacon frame and see if there is going to be anything interesting in the tagged parameters, right? And if you notice, one of the interesting things is there is a vendor specific tag here called WPA, which interprets that. And here you have a lot of interesting things which we will look at later: the multicast cipher suite, the unicast cipher suite, the auth key management suite, right? So you have that as PSK, the multicast and the unicast cipher suite you have as TKIP. So this is one of the key areas which your client actually would use in order to go ahead and figure out what is the access point out there, right? So to give you an example, the little lock sign which is there on the client besides spawn me is because it has detected that it is using an encryption schema just with the beacon frames. The client has not yet connected to it. So let's make the client connect to it and actually look at what is happening out there, right? So let me restart our packet capture. And I think before I should have done that, let me add a filter for the BSS ID of PwnMe. Okay, I think I'm on someone else's access point. Let me add for the BSS ID, right? And I'm typically not interested in the beacon frames anymore. So there goes. And now let me restart the packet sniffing. Let me switch off my interface. The interesting thing you would notice is when you quickly switch off your wireless interface, your client actually sends a deauth message to the access point. So it's not that when you just switch off the wireless interface, kind of it just goes off the air immediately. It actually informs the access point that it is going down, and that typically happens using a deauth message. So now I have switched on the client, and as you could probably notice, it is connected to PwnMe, and there's a lot of traffic going here, right? Let's stop here for a second, quickly scroll up and look at what happened here. So after the deauth, of course, there was a probe request packet, which we can't see because probe requests are just directed to the broadcast address, right? And then you have the probe response packet from the access point. Now, one of the things you will notice is that the probe response packet contains the security settings of the access point as well, right? I leave it as an exercise for you to figure out if the association response contains that or if it does not contain, right? Simple exercise for you. So here is the thing. Now we have to analyze the probe request and check whether the probe request had any of the desired security settings, right? So here is the probe request, which I can very simply get by removing the filter. And you would notice that the probe request itself is not really having anything related to encryption. So what does this actually mean? Well, the client is probing for a particular network, or it is just sending out a broadcast probe request requesting all access points in the vicinity to reply to it, right? When the access point replies back with a probe response, then the client actually figures out what is the encryption being used. So in this case, you actually notice that you have WPA set up here along with TKIP, right? PSK. And once the client sees this packet, it looks at the settings which are currently stored on it and checks whether it has a matching setting for the specific thing chosen, which is WPA, WPA2 or web. If there is a match, it goes ahead and connects to it. If not, well, it would just go ahead and silently discard. Now, the interesting thing is what one could do is bring up a honeypot which sends out multiple directed probes, probe responses, pretending to have WPA, WPA2 or any other combination of encryption and authentication, right? And the client, if there is even a single match in what it is probing for and what is there in its preferred network list, would reply back. Now, this entire thing is actually also taken care in a tool called Wifish Finder. Tool doesn't work well as desired right now, the last time I checked. But probably in the end, we'll take this up when we talk about more complicated honeypots. Anyway, but one of the things which I want to do right now is to change the setting to WPA personal, but actually take up WPA2 with AES, right? As I mentioned, both WPA and WPA2 have the personal option. And this one here just mentions whether it's personal or enterprise. This is the place where you set whether you want WPA or WPA2 and the cipher suite. So let's go ahead, save the settings. So now the access point settings have changed. Now let's go ahead and restart the entire sniffing. We do not want the beacon frames. So let's very quickly go ahead and add our usual filters. Now let's connect my little phone once again. Oops, like always, I forget to start the actual sniffing. I don't know why. Always. Right? And it's connected to PwnMe, as you can clearly notice. And if we go back up here, you would actually see a probe response packet coming in from the access point, right? And this time basically you have a lot of interesting things being mentioned. Actually, let me bring down a couple of these, and just too much of information, right? You have something called RSN information here, robust security network, and here it actually mentions that we are using AES as the cipher suite, while the key management suite is PSK, right? This is the WPA2 personal version, which also uses PSK but uses AES and CCMP based on AES. So this is how from the probe response packet the client can figure out whether it is connecting to WPA or WPA2 personal, right? For enterprise, we'll talk about that later. There's something very interesting there in this entire transaction, but we'll look at it later. Let's not complicate the whole picture right now. Anyway, coming back after the probe response, you would actually notice you have the authentication association phases, and then you have these 4 interesting messages called ePOL, right? Key message 1, 2, 3, and 4, right? Very interesting. And this actually says 802.1x authentication, blah blah blah, and where a lot of interesting data is actually going back and forth. So some of you who may have done WPA PSK cracking but may not have dived into all the details would always hear that what we want is that 4-way handshake, right? If we get the 4-way handshake, we can probably try and brute force the WPA PSK passphrase, right? So, well, if you see there are 4 messages here, I leave the interpretation to you. For those who haven't done anything related to WPA PSK cracking, don't worry, we will go through the whole process in a very systematic fashion in the coming videos, right? Well, my friends, that's all for this video. Hope you enjoyed it. This was a very simple introduction to WPA and WPA2, both the personal as well as enterprise edition, and what are the different cipher suites, etc., which they use. As always, feel free to write to me. I'm always happy to respond to your queries. If you have any specific doubts, you can even post in the comments. That way it will help a lot more people, because I'm sure many of you may end up having the same questions. And that's it. See you in the next video, which will be made very soon, probably today itself. And keep your comments coming. Look forward to hearing them. Thank you. Bye-bye.